Just as a reminder, the test is Monday, and your quiz is also due Monday. I drop one of the 4 quizzes, so if this one would be your drop, that's totally fine. And this test will cover chapter 15 and 16. Okay, we're currently on chapter 17, so if we have time, we'll try to wrap up chapter 17 and get some of those notes out of the way as well. Right, so we went over a common ion effect problem, wrapping up class on Wednesday. And now let's go over another type of problem. This involves using the reaction quotient. And the reaction quotient is Q. It's called Q. We will use Q and compare it to KSP in this situation. So we'll precipitate form of 20 mils of AgNO3, that's silver nitrite, silver 1 nitrite, which consists of silver ion and NO3 ion, is added to 5 milliliters of 0.2 molar NaCl, which consists of sodium ion and chloride ion. The KSP of AgCl is 1.6 times 10 to the minus 10. So the first thing you want to do is write the KSP for silver chloride. That equation is this. So 1.6 times 10 to the minus 10. And then this is going to be plus S, okay, because some of that solid will go this way, and when it does, you'll have silver ion being plus S, and then chloride ion being plus S. Okay. All right, so now we're adding a source of silver ion and a source of chloride ion. Let's calculate the concentration after mixing. Okay, we'll first do Ag plus, which is 20 mLs times 0.01 molar. And what's our total volume? 25 mLs, good. So 20 times 0.01, is that 0.2? I think I had a calculator here. Oh, here it is. 20 times 0.01. 0.2 divided by 25 for 0.008. 0.008 molar. And then we have Cl minus, which is going to be 5 ml times 0.20 molar. Okay, so this is pretty concentrated here. And 25 ml is the total volume. Okay, so what's 5 times 0.2? Is that 1? Good. 1 divided by 25. What is that? 0.004 or something? Oh, 0.04. So our KSP, let's plug these S's into our KSP and see if that is enough to precipitate silver chloride, which has this KSP value. So the KSP is actually equal to the concentration of products over reactants. Okay, so that's S and S, but we'll substitute, instead of S, we'll substitute 0.008 and 0.040. Okay, and see if that equals to its KSP value at 1.6 times 10 to the minus 10. All right, so 0.008 times 0.04, what is that, 0.032 something? 0.00032. And that does not equal to 1.6 times 10 to the minus 10. It does not. So obviously we're in a situation here where either this reaction is going to go this way or this reaction is going to go that way. So to use this Gator rule, you're going to have to put Q first. We'll put Q first and then compare to KSP. So this KSP is given to us at 1.6 times 10 to the minus 10. And then the Q, we just calculated it as 0.00032. That's 3.2 times 10 to the minus 4. This is much, much bigger than 10 to the minus 10. 1.6 times 10 to the minus 10. Okay, where do the alligator jaws point? To the left. Okay, so this is going to go to the left. What is the left? The left is the side with the solid. So the answer to this question, will it precipitate? Will the answer be yes or no? The answer will be yes. Okay, so yes. Mixing this proportion as a source of Ag plus at this volume, at this concentration, with a source of Cl minus of this volume and this concentration is enough to give us AgCl solid. All right, so do that similar thing on the exam. Same thing, just different numbers, but similar situation. Let's do our last two problems here. Right, so what is the solubility of silver carbonate in the presence of 0.10 molar silver carbonate? The KSP of this is 8.1 times 10 to the minus 12. Did I do this? Wait a minute. Where are we then? Oh, we're done?
Yeah, mine doesn't have those questions.
That was 8 and 9.
Oh. So we already did those.
Okay. All right, we're done? Okay. So there are some true-false questions that I'd like to go over with you. I don't know them off the top of my head, but a couple of main points that we've gone over in lecture. What is an example of a strong base? Okay, if you see OH minus, it's a strong base. Anything else? Is it? Yeah, those are the counter ions, so group 1 and 2 hydroxides are strong bases, correct. NaOH, LiOH, I think, what is that, barium OH. Okay, so, but strong base, as long as it's dissolvable in water, these are sources of a strong base. So if you see something like pyridine, okay, or an amine, okay, and what else is a weak base? Anyways, amines, pyrimidines, ammonia. Okay.
Ammonia is a weak base?
Oh yeah, definitely. NH3 plus H2O. This takes a proton, NH4 plus OH minus. So yes, the ammonia is a weak base. It's a source of OH minus, but it's a weak source. Okay? Not many people know that. That's a good point you bring up, Allison. Ammonia, NH3, is a weak base. It is a source of OH minus. It can react with water. So if you see some of these things that you may not have heard of or a weird name, they don't have OH, so it's a weak base. Okay? Anything that's a strong base are your, like Allison mentioned, your group 1 and group 2 hydroxides in the periodic table. Okay, so that's a true-false. There's a question here on Kw. Okay, do you guys know the equilibrium equation for Kw? What's the equation?
Ka times Kb.
Okay, the reaction. This is correct. Okay, what's the reaction? Okay, it's water reacting with itself. Okay, water reacting to itself. Okay, so one of the water will serve as the acid, the other water will serve as the base. So this is Kw. Okay, this is Kw, which is 1 times 10 to the minus 14. So a lot of people will add, so you see water is donating a proton and another water is taking that proton. So a lot of people will add these two waters together and give you 2H2O. So this is Kw. So that is your formula that represents Kw. What happens if you flip this? Okay, what will you get? Okay, and what would this be? Would this be Kw? Okay, it can't be Kw because this is the equilibrium for Kw. What will this be? Okay, what happens if we flip a reaction? What do we do to the equilibrium? What do we do? Do we change the sign? We don't change the sign. What do we do when we flip a reaction? Okay, we take the reciprocal of the equilibrium constant. So while this is Kw, okay, this reaction, the flip, is 1 over Kw. Okay, so what's 1 over Kw? It's 1 times 10 to the 14. Okay, we're going to take that and flip it. No, that's not how we do it. In parentheses. Yeah, 1 times 10 to the 14. So this reaction is 1 times 10 to the 14. Okay, which is fast. Okay, 1 times 10 to the 14 is like super fast, which means it favors the right-hand side. That's what I mean by fast. Okay, where does the equilibrium favor? Right or left for this? Okay, just by looking at the size, it's going to favor the products. Where does the equilibrium favor for this? Right or left? Okay, left. Okay, because you can look at the size of that constant is very, very low. Okay, so proton and hydroxide will give you water. That's just a given. But is water a good source of proton and base? Okay, not really. Okay, I mean, it is, but I think the statistic is for every 1 trillion water molecules, 1 trillion, about 1 will go this way. Okay? So it is a source of H plus and OH minus, but it's kind of weak. Okay? You can gauge that by looking at how low the equilibrium constant is, but the flip reaction goes really, really favors the product side, because when you flip an equilibrium reaction, you take the reciprocal of the equilibrium constant. Okay, so just remember those small things in the back of your mind. Okay. And just a couple other things. Make sure you know what KSP is, formulas for KSP, products over reactants. Okay, no solids go in. Things of that sort. So anyways, there's like 6 or 7 true-false questions that from the lecture. Yeah, KSP equations, Ka, Kw, Kb, pH is unitless. Okay, the pH scale, these are just common themes. Okay, I think you know this. If you know how to solve these problems very well, then you know the true-false very well as, accordingly. So coming back to this, if you flip a reaction that's at equilibrium, okay, how do we know it's at equilibrium? Okay, look at the arrows. If you flip a reaction at an equilibrium, you're going to have to take the reciprocal to get the new equilibrium constant. All right, so there's a 6 or 7 true-false questions as well. Alrighty then, any questions or comments? Alright, so that is the exam. So you can go over this, you can watch the videos, you can go over your homeworks, like just really quickly. You can practice your quiz and turn that in. You can watch the review of this again. So there's many ways you can study for the test to get a good grade. So this test covers 15-16, so make sure you turn in your 15-16 homeworks as well for the 10 points. Okay. Okay, so I think we have about a good 30 minutes, so why don't we use that time to chip away at chapter 17. So I'll just